my name's Lachlan Swain. Today I'll be talking about the Bivariate Statistics project, of which you'll need a copy of the report to follow along with. We were given the task of taking two sets of data from a point of interest and comparing the two. I decided to go with the average assists versus the average score of the 2017-2018 NBA season. The first ever professional assist was recorded in 1946 during the first season of the Basketball Association of America, and has been an integral part of the game ever since. The NBA classes an assist as a pass that directly leads to a score. With this information, we can hypothesise that more assists would mean more scoring. To test this, I've taken the average assists per game per team of last season and compared them to the average score per game of each team. I started by collecting the data off a reliable basketball statistics website, as this was the easiest and most consistent way of having the data all in one place. To discover whether or not there was any form of linear relationship with the data, we had to analyse it via scatter plots. A linear association is decided by the coefficient of determination, R squared, which is given by the line of best fit. Square rooting this value will give you the Pearson's correlation coefficient, R, which in turn tells us how strong the linear association is, and whether or not it's negative. An R value of 1 is the strongest possible positive correlation, whereas a value of -1 is the strongest negative correlation. A value of 0 shows no linear correlation whatsoever. Figure 1 depicts the assist-to-turnover ratio against the total wins for each team during the 2017-2018 NBA season. Given the coefficient of determination is relatively low, showing minor relationship, the next step was obviously to divide the population. The first of which are teams that made the playoffs versus teams that didn't, to try and find a stronger linear correlation. As can be seen in Figure 2, there is even less of a linear relationship. This can be put down to several teams being outliers, such as the Houston Rockets, who have a high win season but a low assist-to-turnover ratio because they generally play isolated offense, meaning they aim to run the scoring through one player. Figure 3, on the other hand, the teams who didn't make the playoffs, has a higher determination value than that of Figure 2. This can be put down to the fact that the lower-ranking teams are not going for the riskier passes to make the score. The assist-to-turnover ratio versus season wins was not giving the correlation we were looking for, so keeping the separated groups, we changed the data collection to assists against average score and then turnovers against the average score of their opponents. Thus, in Figure 4, we see a far stronger correlation than previous data sets due to the fact that to get an assist, one must score. Also, obviously, the top 8 teams from each conference playing in the playoffs are better scorers, bringing the far higher correlation coefficient. Still, however, there remain several outliers skewing the data and not giving the highest linear correlation we can achieve. Figure 5, follows along the path as that of Figure 4 and uses the average turnovers per game against the average score of the team's opponents. However, the linear correlation is virtually non-existent, but there is definitely some form of trend as generally a turnover can be converted into scoring for the other team. Figure 6 once again shows that the scoring versus assists for the non-playoff teams, which has a decent amount of linear correlation for something that shouldn't have much of any, considering the lower ranked teams in theory should have less assists and a lower score. Figure 7 shows turnovers against average opponent's score for the non-playoff teams. The opponents' scores are obviously higher than that of the playoff teams due to them losing much more, as the same with turnovers, yet there is a much stronger relationship, which is entirely expected, as they are ranked lower. We're still not getting a high enough correlation coefficient to confirm that there is a linear relationship. This was decided that we cut the sample down further by only using the top 8 playoff teams. Figure 8 is the top 8 teams' turnovers versus opponent scoring. The linear relationship is very weak as there are many points scattered almost randomly. One major outlier is the Cleveland Cavaliers. As their turnovers are relatively low, however, their opponent's average score is high because they generally play a weak defence. Whilst on offence, they hold onto the ball well until they shoot. Figure 9 depicts the top 8 teams' average score versus average assists per game. Its determination coefficient is only marginally higher than that of Figure 4, which was not expected. As with the top 8 teams, it would be assumed that there would be a much stronger linear relationship. With this information gathered from Figure 9, it was decided that an outlier was to be dropped out to find a higher level of correlation. The Houston Rockets were taken out of the sample due to the high level of isolation ball they played, rendering the need for assists useless as they had a high number of season wins. We were given the highest Pearson's coefficient we've seen in this scatter plot, showing a moderate to strong linear correlation. In conclusion, we can see that there is some form of linear relationship between the scoring and assists put up. The experimental values that we achieved in the final tests were relatively close to the theoretical values that we were expecting. Thank you very much for listening.